What is a calculation? By the end of this episode, you will understand how to represent timeless calculations in your language. My name is Eric Normand, and I help people thrive with functional programming. So this is an important topic. I have a three-level system, three-level scheme for how you can progress in your functional thinking journey. And in the first level, the most fundamental level, you have to make a distinction between actions, calculations, and data. This distinction is necessary for the next two levels. So I've already gone through actions in another episode, and you should look that one up if you're interested. But in this one, we're going to go over calculations. We're going to go over what they are, how to identify them, their requirements, and how to implement them. All right, so let's get started. As a rule of thumb, I like to say that calculations are code, are runnable code. They're computations that do not depend on when they are run or how many times they are run. Now, that doesn't explain much. It's kind of a rule of thumb. It's a way of identifying them. And we'll come back to this a few times in this episode. But really, they are the kind of mathematical function that you think about. Another term that we hear a lot in functional programming is a pure function. It is a function from inputs to outputs. It's a computation that takes some inputs and returns an output. It doesn't do anything else. It doesn't send an email. It doesn't change any mutable values in your program. It simply does a calculation. And when you have one of these, because it doesn't matter when it's run or how many times it's run, it's always going to give that same answer no matter what, then they're easy to test. They're easy to understand how they work. You don't have to look at the whole program and the history of the program to understand how it works. So if you can say, hey, this one doesn't depend on when it's run, or it doesn't matter how many times I run this, I'm always going to get the same answer, then you have a calculation. Now it can get tricky because calculations aren't always functions. That's why I don't use the term pure function, because in a lot of languages, they are, function already has a lot of connotation when you're talking in the context of programming languages. Some more functional languages tend to use functions more, but languages like C and Java and JavaScript and Python, just most languages really, don't always use functions, even when it is a mathematical function. Easy example, addition. In JavaScript, addition is an arithmetic operator. It is not a function. You don't call it the same way as you call a function, and it is not a function. It's a piece of syntax that the compiler recognizes and converts into machine code or whatever. It interprets it, but it's a different way of interpreting from interpreting functions. Okay, so that is one reason why I call them calculations instead of functions, is because function already has a meaning to most programmers. And it's unfortunate. It's sad that it's not the same meaning that mathematicians have. It would be better to have like a more accurate usage of all these different terms, but that's the way it is. Pure function kind of gets at it, but then again, it's function. What about plus? What about times? These aren't functions in most languages. Okay, so when you have something like addition in JavaScript, the plus operator, it's pure. It's a pure function, right? Like in the abstract sense. meaning if you give it the same arguments, it will evaluate to the same answer. 1 plus 2 is always going to be 3, right? A plus B is always going to be C if you have the same values of A and B, right? And so it does make it easy to reason about. But the problem is that operator is not first class. Okay, it cannot be passed to another function. JavaScript has first class functions. You can pass a function as an argument to another function. You can save a function to a variable. You can return a function from another function. You can't do any of those things with the plus operator. And the reason you need to do that is because at level 1, you start doing what are called higher order operations. You start doing map, filter, reduce. You start building abstractions that take functions and return functions, right? You have so functions that operate on functions. And you can't do that with plus. So what you need to do in your language is to find a way to represent all of those things that are not first class baked in and represent them as a first class thing. Okay, that is one of the challenges of doing functional programming in a non-functional language. So JavaScript makes it relatively easy because you can always define a function called plus, P-L-U-S, that takes 2 arguments and adds them and returns the answer. That's easy to write. And it's so small now with the new Lambda syntax that you can do that in line. You don't even have to name the function. It can be anonymous. And when you do that, you now have a function that does plus, it does addition, but it's first class. So you can start doing level 2 things. Did I say level 1? Yeah, first class stuff is level 2. I gotta change my notes here. Right, level 1, just to be clear, because I just messed it up. Level 1 is making this distinction between actions, calculations, and data. Level 2 is higher order thinking. This is data transformation pipelines, it's map, filter, reduce, it's making higher order actions. You need to be able to represent these things as first class values, like you can in JavaScript. In something like Java, it becomes a little bit more difficult. You could look at a method. Let's say it's a static method, and it does not access any mutable state or anything. It just takes some values as arguments and returns a value as a return value. That is a calculation, but it's not first class, right? So you get all the benefits of it being a calculation, meaning it's easy to test, it's easy to think about what it's going to do, it's easy to you don't have to worry about when it's going to be called or like what order it's going to be called in. So it has all those benefits. But what it doesn't have is the ability to pass it as an argument. I mean, maybe with the new Java 8 stuff, they've changed this. But when I was learning Java, you could not pass a method in to a function as an argument or a method into another method. What you need to do, the only thing you can pass in besides the like primitive types like int and stuff, you can pass in an object. So you need to represent your function as an object. And I think with the Lambda syntax in Java 8, you can start doing that. You can represent a single method call as a Lambda. So this episode is not about how to do it in Java, so that might be a different episode, or you might have to just do that on your own, figure out how to do that. But to get to level 2, you need a representation that is first class. Okay, so one thing I like to say about calculations that I think might be clearer now is that they are timeless. Actions are bound up in time. Okay, just by definition. When you look at any action, you can say one of two things. It either depends on when it is run, meaning compared to other things that are running, there is going to be some order where it has a different output. Example, if my JavaScript function reads the value of a global variable to make a decision in the function, so it returns something different depending on what's in that global variable, there's going to be some way that I'm writing to that global variable in some other place that now I need to know about that to know what my function is going to do. Okay. Now, is that good or bad? I'm not judging. I'm just saying we put those in a different bucket because they require different kind of attention. Okay, those are actions. But if it doesn't read any global variables, if it doesn't like read from the network, do anything like that, all it does is it computes something from the arguments to the return value, then I can say that it's timeless. It doesn't matter when it's run. I could run it on a different machine. I could run it right now. I could have run it 2 weeks ago and cached the value and just kept the value. Right? It's timeless. I can free myself from worrying about any issues of time. Can I run it 100 times? Yes, no problem. It's not. I can't say that about sending an email. Like a function that will send an email, I can't say that it's timeless. If I send the email today, that's different from sending it tomorrow. If I run this function 5 times, it's different from running it 1 time or running it 0 times. And so calculations are these things that, because of these constraints we put on them, doesn't matter when you run them or how many times you run them, then we can free our mind and just say, these are in an easier bucket. This bucket is easier to deal with. We can actually pay a lot less attention to them. They're easier to test too. So you can just treat them in a different way. It's like having the difference between like a wild animal and a tame animal. The tame animal will just sit there and kind of listen to you. If you say, hey, shoo, it'll just go. Whereas a wild animal, if you say shoo, like you don't know it might jump out at you, right? So they're in different buckets. Cool. So I've kind of belabored this point, but that's what I mean by timeless about calculations. They're timeless because they're not bound up in time. Whenever you run them is fine. You don't even have to think about it. And this is what functional programmers do, is they put more and more of their code into calculations. They still have some actions. Like you need actions. You need to send that email, But the more we can put into calculations, the more relaxed we can be. Because this stuff is much easier to work with. It's an easier medium. These things that don't matter when you run them. I mean, one of the hardest things about software is getting things to run in the right order. And so if you have a whole bucket of things that it doesn't matter what order they run in, it makes everything easier. It means you can cache them. It means you can, or also another word for that is memoize. There's a whole episode on that. It means you can even figure it out at compile time, right? You can do lazy evaluation, so maybe you don't ever use it, right? Maybe you never need that value. You could just like not calculate it until you really need it. There's all sorts of great stuff you can do once you are like free out of time, right? You're freed yourself from being bound in time. Okay, let's recap. So calculations are computations from inputs to output. They don't do anything else. The rule of thumb is if it's a calculation if it doesn't depend on when it is run or how many times it is run. We'll also call these very often pure functions, but they're not always functions in your language. So some operations in your language are operators and not functions. It's possible. Or they're a static method, right? What we need to learn to do in our language, and every language is going to do it kind of differently, is to convert these things into first-class objects, first-class values. And that's so that we can do level 2 stuff, which is like map, filter, and reduce, that kind of thing. And I like to say that they're timeless. They represent like mathematical relationships. So addition is timeless. It's never going to change. It's been that way since who knows how long, the beginning of the universe, I want to say, but I wasn't there. No one knows if the laws have changed. But as long as people have been around, 2 apples plus 2 apples is equal to 4 apples, and it's just always going to be the same. Cool. This has been my thought on functional programming. I'm Eric Normand. If you want to find the other episodes, the past episodes, you can find everything at lispcast.com/podcast. There you'll find audio, video, and text transcripts of all of the episodes. You'll also find links to subscribe. So whether you want to subscribe on YouTube or the podcast or via RSS if you like the whole blog thing. And also you'll find links to find me on social media. Please get in touch with me. I'm looking for the others. All right. Thank you very much. This has been my thought on functional programming, and rock on.